Really nice to have a confirmation that you can hear me loud and clear. Wonderful. All right. So, I've been told that with regards to the last problem set, some of you have had a go at the remaining exercises, the ones about DAGs, and some of you have not had time to do that. That's okay. I realize that DAGs are an abstract concept that we should probably look at again. What I'm thinking is that we should not do that now, but we'll get back around to have a look at DAGs when we cover commits in the next lecture, because that's where DAGs will be important to know about, or at least that's where we'll see them again. What we're going to do today is to continue to look at Git internals. We're going to look at what Git looks like on the inside, and it's going to tie up with what we've been doing so far. At least hashes will be important today. Although this might seem a bit disconnected from how you're used to using it, just bear with me, because everything is going to come together in the end. So I guess without further ado, we'll continue to have a look at this week's slides. Now, let me see if I can bring them up on the screen. There, hopefully you can see them. And again, if you need to find the slides to follow along, they should all be at umuzi.gitlab.io/get-slides. And I'll give you 10 seconds to bring them up in your browsers. So that is umuzi.gitlab.io/get-slides. Okay, very good. Now, we've talked about what a version control system is. We did that in lecture number 1. We've had a look at hashes and hash functions. And we've talked about DAGs. We'll talk about them again, but at least we've covered them. We've gone through them in a sort of initial attempt to cover them. Today, we've arrived at the topic of Git internals. So, Git internals, this topic will cover how Git works on the inside. The main data structure, or data structures, because there's more than one, but luckily there's very few of them that we need to know about. Really the two components of a Git project that you need to know about are, first of all, the working directory. And that's a very simple concept. That's just the concept of the folder or directory on disk where your project resides. That's your working directory. That's basically where Git knows your project to reside on the disk, and where it will check files out into and check files in from. The reason I'm mentioning that is because it's common Git parlance, it's common terminology to refer to that directory as the working directory. Then, of course, the other main part of a Git project is the repository itself. And as you might remember from lecture number 1, we said that a repository is a file database that the version control system uses to keep tabs on all the files, all the different things that, all the files in your project and all the different things that have happened to your files. So the repository is like the main database of Git. And as you might remember, in a centralized version control system, you don't have a repository on your local computer. There's one computer on the internet or on your local network or somewhere that will keep that database and that you have to connect to. In Git, however, everyone has their own repository. Everyone has their own copy of the database. And working with Git means that you have to keep all these different repositories in sync. So the repository is the database that keeps your files, and it resides in a special directory which is created when you initialize a Git project, and that is the .git directory. And I think all of you have seen that when you run git init, a .git directory is created. Is that so? Have all of you seen that? Or is that something that's new to some of you? So the entirety of the repository, all of the changes, all the files that you check in, they actually go into the .git folder or the .git directory. So then, of course, the question is, well, what does the repository consist of? That database, what's inside it? And the two main components of that repository are the object store, which is where all your files and information about all the directories that you've created and all your commits will be stored. And there's the index, which is an intermediary area where you put files before they are committed. And we'll look at both of these in depth. So I'm just mentioning them by name now, so that you'll recognize the names as we come back to them. Are you still with me, by the way? I didn't hear anyone tell me if they recognized the .git directory. Yes or no? Actually, let me just demonstrate this. Let me bring up the terminal. Can you read what's in the terminal? Because I think I adjusted the font size. Can you please tell me if that is readable? Is it legible? Is it possible to see what's on the screen right now? Or should I adjust it? Oh, you can only see my slides? Absolutely. I set my streaming software in studio mode, so I actually have to explicitly do the transition. There. Now hopefully you should see a terminal on screen, and hopefully the text should be big enough that you can read it. Is it? It's clear? Okay, very good. So let me just switch to my Umuzi directory, and let me create a folder that we will call git-test. And let me switch to that folder. I'll change the directory. Now I'm inside git-test. Okay, this directory is going to become my working directory. When I run git init here, git-test is a working directory for a Git project. Git init, and it's now initialized an empty Git repository in blah 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 /git-test/.git. And if I list all the files in this directory, and I'll have to list all the hidden files as well, because a dot file and a dot directory on Linux will be hidden unless you explicitly ask to have it shown. ls-a, and there's a .git directory. The other two entries that you can see in the list there are dot, which represents the current directory, and dot, which represents the parent directory. You always get those when you list files on Linux. The only directory inside here is .git. Oh, some people are saying the font size is a bit too small and that I should increase it. Okay, let me try and do that. Just give me 1 second here. Let me try and increase that to $18. Okay. And oh, it switched to a different window. Why did it do that? Okay. Actually, you know what? Okay, I'm sorry about this. I'm just going to have to make sure that you can actually read the text. That's pretty important. Okay, there, and let me switch to another terminal window. Okay, there. Is that more readable? Is that better? And Sydney is saying that I can't send text. What kind of text are you trying to send? Is it in the chat? Well, if you're trying to send something, Sydney, and it doesn't work from your computer, maybe ask someone else to send it. Did it just switch the windows again? Seems like my streaming software is acting up. Okay, let me try that again. I think we should be back. Okay. Okay, I think that you should now have a terminal on screen that says that I'm inside a directory called git test, and you should see that we're on the master branch in red. Okay, so let's get back to this. ls-a, we have the .git directory here, and inside that directory, that's where the repository resides. So if we again change the directory to .git, we're now inside .git, and we can list the files and directories here. And you'll see several things here. You'll see directories named branches, hooks, info, objects, refs, and 3 files. One called config, one called description, and one called head. So we've talked about the object store and the index as the main components of the repository. And the object store, that is what you'll find inside the objects directory here. When we check a file into Git, we're going to see that that directory changes. And I'm going to show you that. We're also going to see that once we start using this repository, we're going to get a new file here called index. And all these other directories will make sense later on in the course. Let me try and switch back to the slides. At least you've now seen that when you do a git init, you get the .git directory, and it contains a few files and directories. And they are what constitute the Git repository. So if you move the entire working directory somewhere else, including the .git folder, the project will remain. All the information about what branch is checked out, etc. will remain. So let's move on to the object store. What's the object store? That's the main part of the repository, the main database where Git stores objects it needs to keep track of a project's history. So like any database, what's a database? It's basically a piece of software where you can store information of different types. So by information, we usually mean data that could be put into a file. So saying that it stores a file just means that it stores information that resides inside files. And what was I going to say? Of different types. So we need to be aware of what kind of types of data that the object store knows about. And Git is a very, very simple database. It can save basically 1 out of 4 different kinds of data, 4 different kinds of data structure. The first object that it can store is a file, except Git doesn't call it a file internally, it calls it a blob. So whenever you save file data to Git, it's going to get stored inside a blob. Then it needs to store information about files inside a directory, basically a list that says inside the directory X you find file Y and Z. And that kind of list is called a tree. And then, of course, it needs to store commits, and we will look at commits in the next lecture. So we'll get back to what a commit looks like. And the fourth kind of object that you can store inside Git is an annotated tag. That's basically just a sticker that you put on a commit to say, you know what, this commit is important for some reason or other. And you can add a comment, and you can sign it even, and it just exists in order to, push a pin into a commit, just to say, this commit, this is special in some way. For example, it could be that this is the last commit that was built into a piece of software that you shipped off to your customers, and you're saying this is version 1 of my product and it was shipped to customer Y and Z, and you create an annotated tag to do that. Again, we might look at annotated tags later in the course if we get the time to do it. Otherwise we'll skip them, and you might see them on your own, or you might not. I don't think I've ever used them. Now, let's talk about how things work and move inside the object store. And before we go on to talk about it, let me actually just let me show you how it works in the terminal. And maybe all of you could follow along and do this exercise with me. So could you please bring up your Ubuntu terminals, or your Linux on Windows, the subsystem, whatever it's called, terminals, and tell me when you're ready. And let's do this together. Sounds okay? And are you still with me? Yeah. Jeppo is ready. How about the rest of you? Okay. As you're getting ready, prepare for the following step. We're going to create a file, a simple text file that we're going to check into Git, and we'll see what happens to it. And the way we're going to do this is we're going to use Linux to do it very easily. We're just going to take some phrase or text and echo it. I'm feeling pretty boring today. I'm going just to say hello Umuzi, and we're going to pipe that, or we're going to redirect that into a file, which we can call anything we want really. But let's, for example, call it Umuzi.txt. Okay, so this command here takes the phrase hello Umuzi, puts it on standard output, and redirects that standard output to a file called Umuzi.txt. And you run it, and you get a file called Umuzi.txt. And tell me when you got that file. Let's just double check that it contains what I think it contains. Let's print the content using cat. Yep, we've got some content. Then what we're going to do now is to hash the file to find its hash. Okay, we're going to run git hash object Umuzi.txt and tell me if you don't get the same hash as I do. 00f2, etc. Why are we doing this? Well, this is because, as I've told you before, Git keeps track of things using hashes, meaning that when we put this file into the repository, it's not going to exist as Umuzi.txt. It's going to exist and to be referred to by its hash. So when we now do git add, oh, by the way, I think I might have forgotten to tell you, remember to initialize a Git repository. So if you haven't already, make sure that you're inside some directory that you can use as a working directory and run git init. I'm sorry, I should have started with that as the first step. Make sure that you're inside a directory, for example, by creating a directory using mkdir and give the directory a name, for example, git test, as I did. Do that. Then change to the directory using cd, and then initialize the directory using git init. Okay, so if you haven't already done this, do mkdir git test cd git test and then run git init. Okay, is everyone fine with that? Just tell me if that was confusing. I just need to make sure that everyone actually has a Git repository initialized in the directory where we're working. Can everyone just tell me if that's okay or if that was confusing? So again, just make sure that you've created a working directory and you've initialized an empty repository using git init. Okay, Johan is saying it's okay. Is it okay for everyone else? Just please, everyone, just type yes or no. And it's fine to say no. Michelle, maybe you could confirm whether people are ready or not. Because it's vital that everyone actually is in a working directory that has an empty repository. That's absolutely essential at this point. Okay. People are saying that git is initted and they've got the same hash. Okay, and if everyone still needs some more time, just please yell something in the chat right now and you'll get another 30 seconds or a minute or so. If not, we're going to continue. Okay. Michelle's doing a check. Okay, I'm going to just wait for Michelle to tell me if everything's okay. We're getting there. Very good. Some people are just finishing, that's fine. So I think rule number 1 in broadcasting is that you should never allow for more than 5 seconds of dead air. And I've broken that rule by quite a lot now, I guess. But as soon as Michelle can confirm that everyone's fine, we're going to continue. After you've created the file, again, just create the file. It's nice if it contains exactly what I put on the screen there. Hello Umuzi. And after you put it into a text file, and put it, make sure that it resides inside the working directory, hash that file, and you should get 00F, etc. And Michelle is saying that everything's great, and that's great. That means that we can continue. I'm going to just clear the screen right now, just so it's not as cluttered by text as it is. There. And again, I'm just going to do git hash object and the name of the file, and there's the hash. Okay, what you're going to do now is to add the file to Git. Do that by running git add and then the file name. What we've actually done now is to add Umuzi.txt to the index. And we'll talk about the index later, but the index is basically the area where you put files before you've created the commit. You want to bundle all the files together that you're interested in into a single monolithic commit, a single commit that pushes every single file that you're interested in at once. And the way you do that is that you have this living sandbox called the index, or also referred to as the staging area. And when you use git add to add a file, it will be there will be a new entry inside the index saying, hey, someone added this file. Now that you've added Umuzi.txt, what we're going to do is to switch directories. We're going to change directories to .git. So please do that. And we're now inside the repository on disk. And if you remember from when we listed the files, there is a directory here called objects. I want you to cd into objects. And then list the files and directories there. And you can see that there is a directory, hopefully, that starts with 00. Now, as it so happens, okay, so someone is asking what's going on here. Okay, so what we did was we changed directories to .git/objects. So we were in the working directory of a Git project, and we then changed the directories. We descended into the folder, into the directory called .git. Let me actually do that again. I'm just going back to the top directory. We're now in the working directory, okay? Here is the file that we just saved. Remember that there is another directory here that you can't see right now, but if we list everything, there's a .git directory inside the top level of our working directory. That's the repository. So what I said was, please change directories to .git. Now we're inside .git. Okay? And inside this directory, there's yet another directory which is called objects. So we changed to that directory. Objects. So right now my present working directory is blah 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 Umuzi git test, which is my working directory, .git objects. This is where we are on the disk right now. And as I said, if you list the files here, there is a directory that starts with 0, 0. And let's just scroll back up a little bit. When we had a look at the hash of the file, it started with 0, 0, F2. Oh, it seems like we have an outsider. Is that what's going on? Well, hi Michael, this is a live stream for a class at Umuzi right now. We're talking about Git. So you're welcome to sit in, but it might not make much sense unless you follow the course. Anyway, if we now enter that directory, what do we find? Well, there's a file here. And if you look at its name, F2, etc., you should see that if we append, or prepend really, 0, 0 to the name of the remaining file, F2, C11, etc., that should be very similar to something we know already, namely the hash of the original file. So, what has Git done? We added the file to the staging area and thereby added it to Git itself, to the object store. Git created an entry for it by creating a new file inside its own database, which is named by its hash. So the file lost its identity on disk and is now referred to entirely by its hash, and this is where it exists. Now, if you try and cat the file, you'll see that the content looks garbled. It doesn't make much sense if you try and print it. And that's because Git stores everything in its own binary format, in its own format that is different from the files that you have in your working directory. And there's several reasons for that, but one of them is that it can pack data together. So let's go back out to the working directory, to the root of the working directory. You can do that by running cd ... Dot refers to the directory right above yours, the parent directory. So I went up two levels in the file system, and I should have gone up 3. Now we're back at the top. Let me just check that. Here's Umuzi.txt. Okay, so what did we do? We went into .git, into the objects directory, and we found out that there's been a file has been created there, which corresponds to the file we just checked in. Now, if we want to query the object store and find out, well, I know that we've stored a file and I know its hash. How can we do that? Well, let's make sure that we've copied the hash of the file. Git has a command called catfile. Git catfile. And that can be used to to list files inside the object store. If you just run git catfile, it'll tell you that it takes an argument. You can use catfile to show object type using the -t parameter, show the object size, or you can print it using -p. So if we now run git catfile -t to find the type, and then provide the hash, which I need to copy. Git catfile -t and then the hash. It tells us that that object is a blob, as it ought to be. We stored a file, and a file in Git parlance is a blob, and if we print it, we get hello Umuzi. So now we've basically queried Git's object store to find an object that we stored inside it using its hash. Can you try and reproduce that? Can you try and use git cat file to actually print the content of that file? I'll go through the steps of how you do that again. You do. First, we need to know the hash. In this case, if you don't remember the hash, just do git hash object of the file again, just to find its hash again. That's the hash of the file we're interested in. Then do git cat file, and we want to print it, so -p, and then the hash. And you should see that Git was able to locate that file inside the repository and print its content. Were you able to do that? So we're almost done for today, it seems. Well, we started 5 minutes late, so I'll go for 5 more minutes. Okay, very good. So now we've stored our first file inside Git. If you change the file, or even if you remove the original file, like I'm going to do now, I'm removing Umuzi.txt. It doesn't exist in the directory anymore, but it still exists inside Git. I can run git cat file and find it. Now I'm going to create this file again, because I'm going to need it for what we're doing next. Okay, and it's there. Okay, now we have a directory here, and this directory is important to us because it lists out all the files that we need for our project, and it usually does so in a structure that we need to keep. If we have a library directory, we need to make sure that everything inside that directory, every file that resides inside that directory goes there when we check everything out from Git. Git needs to respect the directory structure of the project. So as I said, there's an object in Git called a tree, which does that. And we've already checked the file into Git. We checked this Umuzi.txt file into Git, and we put it into the staging area, or the index, which we ought to call it. So what we'll do now is we're going to take that index and we're going to create the corresponding tree data structure that the index represents. The index now contains a list of files. Actually, let me show you this. We can see what is in the index by running git ls files -- stage. Now, I'm very sorry that the Git authors are exceptionally inept at naming commands in a way that makes sense. Because I think the official name of the staging area is the index. I don't think it's officially called the staging area. But anyway, in order to run this command on the index, you actually have to use -- stage, not -- index. And I'm not sure why. But what git ls files -- stage does is to show you the files that are in the index. And what you'll see here is that there's one file in the index right now with the hash 00f2, etc., called Umuzi.txt. It's basically telling us that in the root directory of the working directory, at the top level of the working directory, there is a file called Umuzi.txt. Its blob can be referred to by that hash. And well, I'm going to give you 30 seconds to actually run this command on your local computers and tell me if this is the kind of entry that you get. We'll be done in a couple of minutes, I promise. Just tell me if this is what you see when you run git ls files -- stage. Sydney's asking, what's the 0 after the hash? Yeah, that's an interesting detail. Because sometimes you need to merge different commits. You want to merge work from different places inside Git. Basically, you want to integrate different files that have the same name. Whenever that happens, where you're in the process of merging, Git will keep track of which file is merged into which by changing that number. So that number will generally always be 0 unless you're merging something and two files with the same name and the same place in the file system will have to be integrated manually, in which case the stage will show one of them with a 0 and one of them with a 1, I think. The first one, the first number, 10644, those are, if you remember the Git course, if you remember the Linux course that we ran before the Git course, and we talked about file permissions, that 100644, that is actually designating the permissions of that file on the file system. You might remember we talked about octal numbers, talking about execute, read, and write permissions as a number between 0 and 7. This is basically telling us that 644 is the permission that should be set on that file. 100 is also some special permissions that we're not going to delve into right now, but this number is about permissions. So yeah, I think we've explained every single entry here right now. Umuzi.txt, it's of course the path to the file with its file name relative to the root, relative to the top directory. Okay, that's more information than I intended to cover, but there you go. Now, what we're going to do is we're going to take this index and we're going to create a tree object from it. And the way we can do that, the way we can take the index and manually force Git to create the tree object for it is git write tree. So please do that, and you should get yet another hash. In this case, that hash is the hash of the tree object, which is an object that Git created for us. So please tell me if you get a hash from running this. And you might not get the same hash as I did. I have to think about why, but I think you might get different hashes. Now remember, git write tree is written with a dash, so it's git space write dash tree. Now what we're going to do is first we're going to check the object store by using git cat file to see what type this object has. You actually got the same hash? Okay, that might be true. Yeah, okay, there's no time. Yeah, okay. We'll talk about why tomorrow. If you got the same hash, then good. If you didn't, perfectly fine. If we do git cat file and query the type is a tree this time, not a blob. And if we list its content using -p, what do you see? It's the content of the index. It's basically a list telling us that this tree contains the file Umuzi.txt. Okay, I think that's all we have time for today. I'm sorry, it's almost 11 now, so that's a bit, we went on for a bit longer than we should have. We're going to finish up our talk about the object store, and I'm going to tell you why this is important in the next lecture. So let's switch back to the camera. Thank you very much. Now, you might have been given a problem set, and we haven't covered everything that I intended for us to cover about the object store. So not everything on that problem set might make sense, but at least half of the exercises should. So when you do those exercises, try and do as many as you can with the material we've covered today. And we'll continue talking about the object store in the next lecture, and the rest of the exercises should make sense. So, any questions so far? So, thank you very much for listening to me for yet another class. And yeah, I'll see you again next Monday. Why is anyone writing so many errors? Errors is part of the profession. Errors is correcting errors and typos and bugs that you unintendedly create because you typed something silly or something different from what you intended. That's 90% of the job right there. But yeah, excellent. Hopefully this all made sense. If not, ask your instructors, send me an email. We'll continue on Monday. Okay? Bye-bye.